Good day for everyone. Today we will see how to calibrate the demand sectors in an osmosis model using our starter data kits. So essentially the idea of this hands-on is basically first to collect the necessary data for the demand sectors, and secondly to calibrate two things: the start capacity and the energy consumption of these end-use technologies. So according to this, the first part is about to calibrate the residential sector. The main document that we need for this practice is the national energy balance of your country. You need to do some research and look for where this documentation is. It's very important to guarantee that you have the values for all the years starting in 2015. And as you can see in the table 1, just as an example, you have the different consumption per fuel. In this case you have biomass, electricity and oil, but you can have more types of fuel depending on what your country is. Essentially, two energy services are considered here. It is cooking and low heating. The third one is electrical appliances, but in a previous hands-on we discussed how to calibrate the power sector. That is the reason why we are not dealing with that calibration in this exercise. So good. After collecting this data, you can create a similar table, very likely to this, where you have the different values. Please keep in mind that all the values are in petajoules, so in case that you have a different unit, you will need to convert it. So you can do the same for the other sector. So here we have residential, this is the one that we are going to use, but also we have the same for commercial and the same for industry, as we will see later. So in the case of residential, the idea and the second document that we need is the calibration template that is here. As you can see, the first step is about the residential sector. In this kind of pink, you have the values that you need to complete, and the rest of the tables are populated automatically, so you don't need to complete any other values except for the growth rate for the estimation of the projection of the demands based on a driver, like for example the GDP growth. So essentially here we are going to put the values of the energy balance in terms of total energy consumption in petajoules, and after that we can calculate the rest of the values. So assuming that you do the collection successfully, we are going to select the values, we are going to select the values and we are going to copy and paste it accordingly. So here, as we discussed before as well, don't forget to always try to copy everything in terms of values, not formulas, to avoid any issues or errors. So here, as you can see, these values are completed, and automatically the other values are completed as well. Here, this completion is done by some assumptions which are described here. So just in case that you consider that these assumptions are not applicable for your country, you can propose a new ones, but in that sense you will need to also modify the different formulas that you have here. This is a flexible template, so you can play with that as you need. Okay, now this is the energy consumption, but in use, so the difference with this is that these consumptions are split into different energy services, essentially cooking and low heating. And after that we have the input activity ratios for the different technologies, like for example in cooking we have a biomass stove, electrical stove and oil stove, and so on and so on. And with that, both input activity ratio and the energy consumption by energy service, we can calculate estimated final demand using a formulation that is also described in the second part. You are also have a kind of example here about how those values are calculated, so you can go into the different details after this video and reading this carefully. Coming back to our example, we finally have the final energy demand, that is just the sum of the different technologies for one single energy service, and depending on what data you have, you can work until 2022 as is proposed here, or maybe later. But the next to that, we need to project the data. So we need a growth rate, like for this example, let's assume that we will go with 3%, so it would be 0.03, and automatically you have the different projections down here. Again, if you have more detailed data, you can also use other kind of projection, but it's going to depend on what is your data availability. And finally, apart from this part, that is the projection of the demands that we will use in the calibration, we also have the calculation of the annual total technology annual activity lower limit and the residual capacity, considering that the capacity factor is equal to 1 for end-use technologies. Both this annual lower limit and also residual capacity are the same value, so it is not necessary to do any extra steps. And also the calculation of the different residual capacity and the corresponding lower limit through time is also estimated using this template. Once again, the assumptions behind this progression is described in the hands-on, just for your knowledge as well. Okay, so now the idea with this is to do two things. So first, to calibrate the demands, as second, to calibrate the lower limits and residual capacities. So we will need to go to the folder where we have started data kit. In this case, we have the previous version after the power sector calibration, and now we need to do to make a new copy. So we need to copy and paste that. This will be our version number 5, and then we can open it. It's going to take a little bit. In the meantime, don't forget that as we are doing this progressively, we will do the residential sector, after that commercial, after that industry, and finally transport. It's very important that after each step we try to save the file, then run the model, and guarantee that everything is running successfully. So in that sense, we can estimate, or we can see if where the mistake or error is, just in case that we have one. So please keep in mind to do that. I'm not going to do it because just for the sake of time, but it's something, a very good recommended practice when you are working with this kind of modeling exercises. Okay, so now first of all, we need to calibrate the demands. So here we have the calibration of these demands. In this case, we have cooking and low heating. Something that maybe we need to do later is just to update the codification, but for this case, let's remember that, okay, let's first of all, let's remove this filter for the technology, and now we're going to calibrate the demands. Let's remember that when we don't have any intra-year resolution, that it was the case of the electricity demands, we don't need to use the specified annual demand or the specified demand profile, but instead of that, we need to use the accumulated annual demand. So in this case, we're going to filter that parameter, accumulated annual demand, and we need the demands for the residential. So we are talking about residential, in this case CKN, and residential HEL. This is the one for cooking, and this is the one for low heating. So correspondingly, we need to go here. We're going to copy the one for cooking, then come back to the model. This is over here for cooking, and then we just need to paste it as values. And the same it would be for the case of low heating. So we just need to copy, then go to the file, and then change it according to the values. So sorry, I made a mistake here. We need to copy this as the time series, and then we can copy this as values, and it's okay. Okay, so this would be the practice for the case of residential. essentially just update the demands, and then after that we can do the same for the lower limit and the residual capacity with the values of the template. So here we have the residual capacity, and a little below we have total technology and activity lower limit, that is here. So we can select it, and we will need to select the one for the residential technology. So in this case, let's remember that the codification is dem res, and in that sense we can get the different technologies. Very probably we will update the template with the codes just for giving you the complete information about that, but just for this case, let's remember that, for example, in the case of cooking, we have cooking as biomass stove, by electrical stove, oil stove, but in this case let's do this for biomass stove. The codification is essentially dem res ckn bio, so it's this one. So we just need to go to the values here, once again copy the time series, go to the residual capacity for that technology, then paste it, then go to the lower limit for the same technology, then res ckn bio, locate the value, and then paste it again, and that would be all. Let's do a second example as we did before. We have oil stove, so we just need to copy. In this case, the codification, it would be then res ckn oil, is this one. So once again we need to copy, and we'll repeat the same process for activity lower limit. So here we need to locate it, the ckn oil, and then once again we paste it, and that would be all. We need to repeat the process again for our other technologies, like for example here biomass heater and also the electrical appliances, but as I mentioned before, probably we will need to update this template just for indicating what are the different codifications that you need here. So no worries about that. Now let's go to the second part of this exercise. That is essentially a repeat part, because it's just to do the same, but this time for commercial and public services, just for giving you a second round of what is the kind of process that we need to apply. Let's remember that in our template we have the second tab with the commercial. It's essentially the same. We need to complete the first part about the energy balance for the commercial and public services. One important thing is that just in case that you have other sectors, like for example agricultural or mining, you can try to add those energy flows to this sector just for completing kind of the whole energy sector. However, as I will see very later, the transport sector is not completely model, so at the end of the day this initial model is not the whole system but just one simplified part. Okay, so going to our gathering an additional file. Here we have the values for commercial, so we just need to copy those values that were gathered in a previous stage, go here, copy those as values, and automatically you will have all the tables completed. Don't forget please to complete the growth rate, so let's go with 3% once again, and that will be all. And essentially we need to do the same. We need to complete the accumulated annual demand for low heating in this case, and also the activity lower limit and residual one for commercial, and let's do another round of that. So going here, let's save it. We can start by this part first and then to do the accumulated just for saving some time. So let's go with the commercial end use technologies. The initial abbreviation is DEM-COM, right? So here we have different technologies, and with this essentially in our template we have the first, that is the heater with biomass, So it's this one. We can copy. Then we can go here. This would be the com hit bio. So it's this one. So we just need to copy and paste that. The same would be for this one. So we can copy and paste it, and that will be all, and we can repeat the process for the other one. So for example, here we have with oil, so it would be just like the same, but this kind it would be then com he oil with this one. So we just need to copy. Sorry, I didn't copy here. So we just need to select these values, copy, then go to the template, select and copy, and again locate it for the lower limit, and then go for the values, copy and paste that. And the same for the other technologies. That would be all for the case of annual lower limit and residual capacity. Now let's do the accumulated annual demand. So in this case, we remove the filter for the technology, and then we look for the accumulated annual demand parameter. We select it. Now we need to locate the commercial heat demand. They would be com HEL, that is this one. We need to go here. Let's remember that the final energy demand is here, over here. We just need to copy the values, select it, go to the template, locate the demand, and finally paste it. Okay, that would be all. That would be the second part. As you can see, it's just like an iterative process, because it's essentially the same, and you have the different explanations and more graphical examples here. And in the third part, we have the industry sector, and once again is basically the same. So you have to collect the energy consumptions for the industrial sector from your national energy balance, and it would be like this one. Then you can copy those values just like this, then copy. In our calibration template, you have again the third tab is about industry, so you just need to copy the values or complete it according on how you have those values in any format that you have it. And again, the growth rate is important, 0.03. For this example, you need to determine what is the best growth rate estimation for your specific country. And then once again, we need to look for the industry high heating demand, low heating demand, outdated values, and the same would be for the annual activity lower limit and the residual capacity, just following the same process that we did for residential and commercial. That would be essentially all. And now with respect to transport, we have a different approach, because as we are just modeling passenger transport, just cars, motorcycles, and buses, and we are like neglecting or giving away other types of transport modes, like for example freight transport or maritime transport or air transport. It is not possible to use the energy consumption, because usually those values are aggregated, so it's very difficult to split it, and we can try to avoid so many assumptions in this part. So instead of that, we can use the fleet stock as our proxy for this calculation. So it would be essentially what is the number of vehicles that you have in your country by mode and type. So it means, like for example, car powered by gasoline, or car or motorcycle powered by gasoline, or bus powered by diesel. Notice that another assumption that it could be is like you can have car powered by gasoline and cars powered by diesel. So as we don't have diesel cars represented in the starter data kit, one possible assumption would be to combine those numbers of gasoline and diesel for just this case, and later with more time you can try to create new technologies for diesel car, for diesel, for example gasoline buses or minibuses, is that is the case, and then to do a more disaggregated fleet stock. but just for this case, the idea would be just to make it simple and work with the data that you have. Also, many times it's difficult to collect this data, so maybe you can try to use some interpolation, because let's, for example, imagine that you know the values in 2015, but it goes just until 2019. So in that case, you need to extrapolate the rest of the values. Or it could be the case that you have values in 2016 and you have values in 2021. In that case, you will need to do some interpolation to calculating what is the values between different years. So being said that, we need to complete this. So once again, you can collect the values in a different cell just for keeping the order of the template. And now we can just copy the values, go to our template, and then you can copy the values. One important thing here is that despite these economic parameters are colored in green, and it means like it could be completed by you, it's also difficult to get those values for a specific country. So here you can use these default values, but just in case that you consider or you have very good data about what is the activity factor, load factor, energy intensity, in that case you can use different values just according to your country. So they are here provided just for making the calculations quicker, but just in case that you can do it, you can modify them. Now these calculations are pretty similar to the previous one. Then you can go to the supplementary material about road transport modeling just for checking how these calculations are performed, but they are just calculating automatically. And then you have the input activity ration. Once again, they are part of the starter data kit, and you have the calculation estimate the final demand, and the final demand as an addition of the different modes of transportation. And once again, we need the growth rate here. Like for example, let's assume that it's 3% once again. So you have here these values calculated. Notice that just for this case, for transport, we don't work with petajoules, but it would be, in this case, gigapassenger kilometer as a transport unit for demand, okay? And again, we have the activity just in terms of final lower limit and residual capacity, more or less the same that we did before. So just let's do once again, this example just for giving you the case of this, but it's essentially, don't forget, you need to complete this part about the fleet stock and also what is the growth rate, and with that you will have everything done. So you will need to copy and paste it to your starter data kit easily. So in this case, for example, we have the current transport demand. So we can copy these values, then go to your starter data kit. In this case, the name of the current transport demand is truck car, is this one. So we just need to put the values here and then copy them as values, and that will be all. We can repeat the process for motorcycle transport demand and also for buses transport demand. It would be essentially the same process. Now let's go again with the other two parameters that we use in this calibration. The first one, the residual capacity, and the second one, the total technology annual activity lower limit. This is this one. And this time our filter for the technology will be transport technology, so it is them, tra, and with that everything will be selected. Here we need to take care of selecting the correct technology. Like for example, if we go to our template, we can find the cars fueled by gasoline, so we can select these values, then go to our template, to our starter data kit. Let's remember that in this case the abbreviation is dem tra car GSL, right? So it's this one. So we can select it, copy, and it would be the same for the lower limit. We need to locate it, so it's this then truck car GSL. So we can once again copy and paste it, and that would be all. You need to repeat the process for motorcycles and also for buses, but once again it's the same. At the end of this Don't forget to save and then run the model. But just sorry for being so reiterative about this, but after doing the residential sector, save your file, create your input data file, run the model in the OSeMOSYS cloud or locally, and check that everything is correct. Then go to commercial, do the same, update, calibrate, save, run it, check that everything is okay, and then go to industry, do the same, and then finally go to transport and repeat the process. Okay, so please try to be very judicious on how to do each step, just to guarantee that everything is performing correctly. Good, perfect. So essentially, that is the final part for calibration. So here you also have the hands-on for checking all the formulas and anything else that you need. And essentially, that would be all for this hands-on practice. Thank you so much.